The discovery of a neutron star emitting unusual radio signals is rewriting our understanding of these unique star systems. Dr. Manisha Caleb and her colleagues made the discovery when observing the Vela X1 region of the Milky Way, about 1,300 light-years away from Earth, using the Meerkat radio telescope in South Africa. They spotted a strange-looking flash, or pulse, that lasted about 300 milliseconds. The flash had some characteristics of a radio-emitting neutron star, but the researchers say it wasn't like anything they'd seen before. What the team did is they scoured through older data from the region in hopes of finding similar pulses. Interestingly, they did identify more such pulses, which had previously been missed by their real-time pulse detection system, since they typically only search for pulses lasting some 20 to 30 milliseconds. A quick analysis of the times of arrival of the pulses showed them to be repeating about every 76 seconds, whereas most neutron star pulses cycle through within a few seconds or even milliseconds. The team's observation showed PSR J0941-4046 had some characteristics of a pulsar or even a magnetar. Pulsars are extremely dense remnants of collapsed giant stars which usually emit radio waves from their poles. As they rotate, the radio pulses can be measured from Earth, a bit like how you'd see a lighthouse periodically flash in the distance. However, the longest known rotation period for a pulsar before this was 23.5 seconds, which means the researchers might have found a completely new class of radio-emitting object. The findings were published using all the data available from the Meertrap and Thundercat projects at Meerkat. The team managed to pinpoint the object's position with excellent accuracy. After this, they carried out their more sensitive follow-up observations to study the source of the pulses. The newly discovered object is a peculiar radio-emitting galactic neutron star which rotates extremely slowly compared to other pulsars. Pulsar pulse rates are incredibly consistent, and follow-up observations allowed scientists to predict the arrival time of each pulse to 100 millionth of a second. Apart from the unexpected pulse rate, PSR J0941 is also unique, as it resides in the neutron star graveyard. This is a region of space where scientists don't expect to detect any radio emissions at all, since it is theorized the neutron stars here are at the end of their life cycle, and therefore not active or less active. PSR J0941 challenges our understanding of how neutron stars are born and evolve. It's also fascinating, as it appears to produce at least 7 distinctly different pulse shapes, whereas most neutron stars don't exhibit such variety. This diversity in pulse shape, and also pulse intensity, is likely related to the unknown physical emission mechanism of the object. One particular type of pulse shows a strongly quasi-periodic structure, which suggests some kind of oscillation is driving the radio emission. These pulses may provide astronomers with valuable information about the inner workings of PSR J0941-4046. These quasi-periodic pulses bear some resemblance to enigmatic fast radio bursts, which are short radio bursts of unknown origin. However, it's not yet clear whether a neutron star emits the kind of energies observed in fast radio bursts. Dr. Caleb says if they find it does, then it could be an ultra-long period magnetar. Magnetars are neutron stars with very powerful magnetic fields, of which only a handful are known to emit in the radio part of the spectrum. While we have yet to actually identify an ultra-long period magnetar, they are theorized to be a possible source of fast radio bursts. It's unclear how long PSR J0941-4046 has been active and emitting in the radio spectrum since radio surveys typically don't usually search for periods this long. No one knows how many of these sources might exist in the galaxy. Also, the team can only detect radio emissions from PSR J0941 for 0.5% of its rotation period, so it's only visible for a fraction of a second. The team feels pretty lucky they were able to spot it in the first place. Detecting similar sources is challenging, which implies there may be a larger undetected population waiting to be discovered. This finding also adds to the possibility of a new class of radio transient, the ultra-long period neutron star. Future searches for similar objects will be vital to our understanding of the neutron star population. If you like this video, please consider subscribing and click the notification bell so you do not miss any upcoming videos.